boom, boom, boom. Let me pick the ones that I've never attempted. Oh, I've never touched mic. Where is it sounding? Is it here? Okay, the audio is fine. Opu. Let me wear my opu. Bom biti 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 bom bom. Bom biti 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 bom. Bom biti 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 bom bom. Bom biti 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 bom. Is anybody on YouTube? Nobody on YouTube. Thanks for not joining. Regular expression mapping hard. I'm not ready to do any hard tests now. Maybe. Okay, I've not tried this one before. Let me try 4 sums. Generate parentheses. Have I not done this before? Okay, let me just add it. Next permutation. Permutation. Sudoku. Okay, 4 sums. 4 sums. 4 sums. Think I'm ready to start. Sorry, sticky. So go live here. I'll bring the camera. Should I use super sauce instead? Let me try super sauce. Okay. So one is better, super sauce for the remaining, for the other one. Okay. Just need to do my picture in picture. This should be fine. Bom biti 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 bom bom. Bom biti 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 bom. Bom biti 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 bom bom. So if I switch, it should be like this. Okay, this looks good. This looks good. Let's do it. Okay, dokie, smoky. And yeah, I'll figure out how to do this chat stuff. But for now, thanks for everyone who has joined. Let's get into business. Given an array norms of n, don't know if I should share my screen yet. I think it takes too much time whenever I share my screen, but I would have loved you guys to see what I was doing though. Can I do picture in picture in picture? Too much complication. And given an array of n integers, limited integers, return an array of all the unique quadruplets. Okay, such as number A, B, C, D, okay, such that 0 is less than A, B, C, or D. So the quadruplet that I'm returning is always greater than 0, or greater than or equal to 0, and the numbers are less than n being the number of integers. Given an array of n integers. Okay. A, B, C, D are distinct. They have to be different. Number A plus number A, B plus number C plus number D must be equal to the target. Okay. N is the length of the array, right? Yeah. So you may return the answer in any order. Okay. So return every type of quadruplet that gives us the value 4. So this is 1, 2, 3. Based on this answer, this is 1, 2, 3, 4, 5, 6. 6 the number of elements, 6 numbers in this array. So none of the A, B, or C must be equal to 6, equal to or greater than 6. So our target is 0. So what 4 numbers can give us 0? Okay. What 4 numbers can give us 0? Okay. Okay, our output will then end up being -1, -2, -100. It says in any order. What's in any order? You may return the answer in any order. Okay. How does that translate? I don't get. So this one is -1, -2, -1, 1, then 2. So that's -2, then go all the way. I think it's sorted in ascending order. I think that's the case, because this is less than this, this is less than, sorry, this is less than this, which is less than this, which is less than this. So okay, so it has to be in ascending order. Okay. We just need to find all the pointers for that combination. So each of these combination must be distinct. So we should not return this combination anymore, but we can still reuse the same the same integers. Okay. Okay. 2200. We cannot take 2200 and return that here in any order anymore. Okay. 2200. Okay. Okay, so I'm going to just look at chat once, then I focus on here because I can't hear you. Never mind, I'm still in Zoom kind of call. Okay, so you can hear me, I hope. Okay. Okay, let me mute this one. Also, let me pause this one so that I don't use too much bandwidth. Okie dokie. So this will require me to do some writing because my brain is not braining right now. And I hope you guys will be able to see what I am doing. Bomb BT bomb bomb. Bomb BT bomb bomb. I think this should cover it properly. Let me see. Let me see. Let me see. Okay. This is for my iPad. Okay. So if I do 4 here. Okay. It looks good, but it's wasting so much real estate. If I do this, it's fine. If I do this, it's shit. So let me just go to super source. But the problem now is super source is taken from here. So let me go back to switcher and switch. So sorry, I'm using you guys to learn how to use this device also. So thank you for joining. Thank you for being my experiment. Okay, so that will be my iPad. Okie dokie. So we have a combination of, take for the example, 1, 1, 0, negative 1, 0, negative 2, and 2. Okay, just thinking about it right now, I think if I sort this, it will help me a lot. So that will be negative 2, negative 1, 0, 0, 1, and 2. I think. Yes, there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So yes. So sorting this seems to make it a little easier because we don't need to maintain the order and the answers that was required of us here needs to be sorted and distinct. So I think that will work. So that's one down. What other thing can we do to get what we need? If our target is K, is it K? What do they call target here? Let's just call it T. If our target, let's say in this example, is 0, and we need to go through this whole loop, or rather this whole array, we will need to point to 4 distinct places. So let's assume initially we point everything to the 4 first places. This is our first distinct, since they have to be different and distinct. If in our initial we know that our 4 distincts are are equal to 0, or if they are greater than 0 or less than 0, then there is hope to move forward. But if they are equal to 0, there might also still be hope to move forward. So what I will say is, if our first initial, rather, let's say our current sum, if our current sum is equal to or less than 0, or let me just say target to make it more, is equal to or less than t, then there is hope. Is equals to hope. We are speaking English. So hope in this case will be we have the opportunity to move movable anchor. So an anchor that we feel we can move. So for now, our movable anchor can be the last anchor. So this will be I, J, K, L. So movable anchor right now. Sorry. Our movable anchor can be equal to L. So I'm not even sure. Are you guys seeing me well? Yes. So if 2 plus -2, -1, that is -3, plus 0 plus 0, this is equal to -3. Still -3. So our current sum here is still equal to -3. So if we say let's move this current anchor, that means our current sum at this stage when we move is -2. If we say okay, let's move L again. Should I move L, or let me just move if I keep moving L only, won't I lose opportunity to get any combination that L touches? Okay, so let me not move L. Let me find a way to check whether there is space between L and where there is actual space. Sorry, I'm trying to think of something. So what will cause us to move L when there is? We will only move L if L, we'll move current. There are 2 conditions we need to meet. If so all of these are positions. We'll only move L if it's a little confusing. Okay, I think the safest way is just to move L. Then when we are done moving L, we can then come back to think about moving K, because if I try to make this in a way we move them in between each other, I think we might have an issue. We will miss some things. So okay, so let me just say we move L again. let's just say we move L again. Let's just go through it and see whether it will work. We move L again. That will be -3 minus -3 minus 2. That will be -1. We still don't have 0 here. So what do? Let's move another thing. We say, okay, let's move K by 1 level, but reset L to be after K directly. So in this case, should I do it backwards? If I start from I think I'm doing this thing. I'm overcomplicating this thing. Okay, so let's say okay, let me just continue. What's the sum here? The sum here is -3 and +1. Our current sum here now will be -2. So if I move this, if I move L to 2, our current sum will be -1. Abi? Yes. We still don't have 0, which is our target here. Let me change the color. This is our target. We still don't have 0. Our current target is this thing. So with this being said, we need to move K. If we move K, now I'm a little confused. Am I moving the right way? I'm not sure I'm doing this the right way. So I'm moving K now. K is my only cause of concern. But why did I move? Why did I move L? I know you belong to God. Okay. So target, next target, next target. Okay, let me just go through it. So K is now 1. If we do this, then that means our sum will now become -2 and -2. So this -3 minus -3. So our sum now after moving K will be 0. Sorry, not negative anything. This is now equals to 0. So this is a good pair. Alright, this is a good quadruplet, whatever the case may be. So our first quadruplet will be so let me just say Q's. Our first quadruplet will be -2, -1, 1 and 2. I'm not sure you guys are seeing it well, but this is what I wrote. Our first quadruplet will be -2, 1, 1, 1, -1, 1 and 2. So we need to find our second quadruplet. So they have to be distinct. The only way this can be distinct is to move J. So if we move J, we have to reset K and L. We have to reset K and L. Okay. So in moving J, we reset K and L. So our sum in this case will be -2 plus 1. That's -1. It's not good enough. -1. This is not a good quadruplet. So we move L. So now our sum is now is equal to 0. So this is a good quadruplet. So that will be -2, -1, -2, 0, 0, -2, 0, 0, and 2. This is our second quadruplet, which is correct. Okay, so we still have hope because there's still space between these. So we move K to one step ahead. So that will be, this will be equal to 1. This is not good enough, so we move, since there's nowhere to move K anymore, we move J. We move J, still the same thing. The sum is equal to 1. Not good enough. So we can't move J anymore. We can only move I. We can only move I. So we move I. I'm not even sure you guys are seeing what I'm doing. Sorry. We move I and we reset the other ones. And we go through the same thing again. We check whether this is a valid sum. -1 and 1. Yes, it's a valid sum. The sum is equal to the target. So we have another quadruped. That will be -1, 0, 0, and 1. So this is correct. We're not done because we've not reached our limit. That is to say, L is still, as long as L is less than or equal to the length -1 and I is less than or less than, sorry, oh, what's wrong with my this thing? Delete now. I is less than the length minus the length minus 4. Is it 5? Let's say 5. Length minus 5. As long as these two conditions are met, as long as these two conditions are true, then we can still keep doing what we are doing. So let me just confirm my mathematics. So this is position. If I ever passes this position, we need to break it because yeah, so this is position 0, 1, 2, 3, 4, 5, position 5. This is position 2. So if I ever gets to position 3, and then we have a problem. Position 3 is actually 6. Our length is 6. 6 minus why is it 4? Why did I say 4? So that will be 6 minus 3. What happened? Yeah. So that is length minus 3. Because you're doing less than. If you're doing less than equal to, it can be less. To make it more coherent, I would say less than or equal to, so that I don't get confused. My brain is dot braining well. So let's just say 4. Yeah, so this is, as long as this is true, we can continue doing this. Okay. So where did we stop? We added this last one, have we? Okay. So now the movable position for here is L. I still don't know what logic I can write to make this always true, to know which one to move, if I am being honest here. So move to L. So our sum now is negative 1 plus 2. That's equal to 1. It's not a good sum, so let's move this one. What's our sum here? Our sum is negative 1 plus 3. It's increasing. It's not a good sum. So our sum here now is still 2. If I move this one and we move it here, our sum here is not good enough. It's not good enough. So how do I know when to stop? Should I just reach the end and use the position to know when to stop, or I can also infer using the value of of I. If I is already greater than target, okay, there's no guarantee because the rest can be 0, 0, 0. So if I is greater than target, the rest must also be great. Let me just run it down to the end. So right now, I is equal to I has been moved. L has been moved to the max. Everything has been moved to the max. I has been moved to its max also. So I don't want to do for loops. That's dangerous. That's just crazy programming. How do I do it where I can loop through all of them, but maintaining 1 point for each? Maintaining 1 point for each. That I don't know. Me no. That is to say, what I'm trying to say is wait, let me see. So if I break them down, is anybody in chat? Anybody trying to help me? Nobody. Activity filter is too quiet. Okay. It's fine. Okie dokie. Okay. A, B, C, D, A, B, C, D, A, B, C, D. So the first one is basically find keep moving keep moving L till you get to the end, then start moving moving. Okay, so if we have some form of logically, if we start from beginning, that will be um that will be if I have sorry if I have, let me just copy this again, -2, -1, 0, 0, 2, no, 1, then 2. So -2, -1 and 2. This is basically saying if I have I, J, K, L, that's functionally that will be whatever function this is. Whatever function this is, take from Give me the two positions for okay, so my current is -2. Give me 3 more for 3 more positions for the array of -1, -0, sorry, I say -0. Sorry, 1. I don't want to get the answer. I just want to think through this and get better at it. Okay. So in reality, whatever this function does, this is my current value. Get me 3 more points, and I need to state the target. The target is already known. It's universal. Okay, the target is already universal. It's already outside. The target is somewhere 0. But shouldn't the function work without the need for let's just work with this. Okay, so this is something. So conceptually also, if we do it in a recursive manner, the function inside will still call the same function, but say my position is whatever value is in the J portion. So this one will be whatever value is in the I position, then get me 2 more values, and whatever the subset of from J to the end, to the length of the array. Abi? Still complex. My brain is not braining. Think I'm making it too complex. Can't I just go through it in one loop? I don't think so. It has to be some form of recursion. It has to be some form of recursion. Hmm. Hmm. I'm trying to put my brain to it. Okay. So in the base level, wait. ABCD, ABCD. No, it's not going to work. Okay, so let me just see. Whatever this function is, if for some reason we have to go to the base, to the base. We have to go to the base. We have to go to the base, go to the base, go to the base. Okay, let me just write it down, finish. So that will be a function of whatever j position is, and our current sum up to this level, our current sum up to this level, that is to say, in the example we have, why did I put 3 here? Okay, sorry. Okay, the amount of anchors we need, Abby, yeah, the amount of anchors we need. Who is that? Are they stream? Chat me. Chat me. Chat. So if we have 2, that's for the J1. Sorry, let me write it well. J. That means we'll have something like 0, 0, 1, 2. because here it will be minus negative 1. So we'll have to do another function up to the level of k, which will be a 0. Then we say we want only one more anchor after this k, so that will be 0, 1, 2 up to there. Okay, so at the base level now, this is ijk, we need to get to the base level. So at the base level k, sorry, L, we say we don't want any more anchors. We are only left with is it wise to exclude? Is it wise to exclude what we have? It's not wise. So instead of putting the k value and the I value and whatever value is here, I should just say, since it is I, what's our current sum? What's the so this will just be a position then. It will just be a position. There's not even need for a position, if you ask me. There's no need for a position if we Abby? No, there is. Or let's say our parent sum, as in the sum of the anchors before before us. So for this one, the sum of the anchors before us will be 0. No, will be negative 2. Sorry. Abi? Yes, that makes sense. For the J1, the sum of the anchors before us will be negative 3. No, doesn't make sense. Doesn't make sense. Because we will be moving the J inside where we are already. We'll be moving the J, so this will be, wow. Okay, this will be 0, so that I can include the negative 2 here. So for the J, the sum before us is actually negative 2. Negative 2. Why we need 2 more anchors? There are 2 more child anchors. So that will be negative 1. Okay. For the K, the sum before us at this particular position is the sum before us at this K here will be negative 3. So we still need So at L, the sum before us, taking this as our truth, our first truth rather, the sum before us will be -3, still -3. We don't want to go any deeper. So that will be 1, 0, 1, and 2. In other words, level K can only move 4 levels. Can only move 4 times down. I mean, not level K. The algorithm should only move 4 levels down. So this is only going to happen using this. We're going to use this as long as the level. So I'm considering this should be our level then. Sorry. What's my function? Okay, yes. So we don't go deeper if our function level is equal to 0. Okay, so this should help us stop here. So now on the base level, we should be able to move our anchor. We should be able to move our anchor. Abby? They turned me into a madman. My brain is thinking about 5 different things right now. Okay, so on what condition can we say we need to move? Oh, so we can only move from zero, come on now, type something, 0 to this is our sub array, sub array length minus our level. That's the only place we can move. So we can, in this case, we can move to 0, 1, 0, 1, and 2. So that is 0, 1, 2. We can move to 0, 1, 2. Position or not value. When our length is equal to 3, when our length is equal to 3 minus our level, 3 minus level, our level here is 0. So that will be level plus 1. So that will be level plus 1. We can only move to whatever level we are plus 1. So we're allowed to move this. So if we are allowed to move it, the level plus 1, how does the function know? So it's a while loop. So while that function is allowed to run, we keep incrementing um, the position that we have. I'm back. I was on a call and I had to head out. Okay, no problem. And I'm about to head out. Okay, no problem. Thanks for joining. God bless you and safe journey on your way out. Okay. I think there is some form of breakthrough here. Okay. So I can loop until. Okay. I'll loop until. Okay. Okay. I think I can do this now. But let me try and see if I can write it in form of pseudocode. So we have a function, a iterative function, a function that takes in the current sum and it takes in the level that you are in, and it also takes in the array that you need to work on. So the goal of this function is whenever the target sum is met, whenever the target sum, in this case it is 0, whenever the target sum is met, we need to also accumulate the quintuplet. Is it quintuplet or quadruplet? Quadruplet, sorry. The is it quadruplet? I don't know the English, I beg. The quadruplet of numbers. So whenever our sum is achieved, we add it to the quadruplet. So we go through, we start at current pose. Let's just say our current pose will always start from 0. Abi? Okay, so we do a while loop. A while loop from 0 to what did I use? 0 to greater than or sorry, less than or equal to. I hope my calculations are right. Less than sorry, not 0, position, where the position as long as the position is less than or equal to the length of the array minus the level plus 1. So while this is true, we have the opportunity to check whether we get the sum. Let's say the t-sum. The t-sum now will be equal to the sum plus no, I think the best thing to do here is to only check if we are level 0. If we are level 0, that's when we should do anything. I think. Yes, if we should only do something when we are level 0. So if we are not level 0, do something else. So let me just see. Let me move this down. So if we are level equal to 0, then we should do this. Or let me say, if we are not level 0, sorry for my writing, code and pen is not the same. If we are not level 0, then we should call the next iteration, the next iteration level. So if we are not level 0, okay, we need some way for this iteration to stop also. So if level is greater than, is less than 0, we break. We break. If level is equal to 0, no, if level is not equal to 0, we need to handle the next iteration level. That will be, we'll call the same function. We say our current sum will still be the sum of what our original sum was, but we have to reduce the subset, if you get what I mean. So that will be whatever the sum was in the beginning, Abby? Whatever the sum, no, this is not correct. This is whatever our internal sum is. So our internal sum will have to be sum plus array at whatever position we are in now. Array at position. So I need to move something, sorry. So position needs to be defined, which is, I already did that, but I erroneously moved it here. Okay. Sorry. So if the level is 0, while level is less than 0, break. Okay, that's fine. While level is not equal to 0, when the level is not equal to 0, what do? We call the next level. But if we call the next level immediately, that means there is no room for position to increase. We need position to increase. So this is supposed to be above this. So thank God I'm writing this down. No, I don't want to increase down. I think this is fine. While the position is less than and equal to distance. Yes. Okay. So Is there even a need to say while? Okay, I think there's a need. While level is not equal to 0. If level is not equal to 0. Ah, my brain. This should be called regardless. This should be called regardless. Abby? Yep, I think it should be called regardless. Okay, let me just leave it this way. If so this will be an else. So it will be only called once. So that will be sum of array plus whatever the position in that array is right now, then which is the old sums. We say the level now will be level minus 1. Level minus 1. Then the array will have to be a subset of what we had based on this current position. Not enough space. Sorry, guys. Not enough space. Not enough space. In short, let me move this whole thing. So that will be a subset of a new array from bum bd bum bum from whatever position we are, the next position. So that will be position plus 1 up to position plus 1 up to the end of the array. I think that should do it. So something like this, end of the array. Yeah. So now, if we are actually at the end of the array, if we are at the end of the array, or rather, if we are at the end of the level, so level 0 will then be, we have to check what's our sum value, what's our current sum value at level 0. That will be whatever sum we inherited as our parent sum plus our positional value. That will be array at position. Okay, so if we have this, and if tsum is equal to our target, then we should just add to our quintuplets. We should append to our quintuplets. Do we even know what to add in our quintuplets? If I know my current value, do I know my parent's value? And do my parents know what value? Okay. We know the sum, but we don't know our parent sum, our parent array. Okay, so we can fix that by, instead of sending the sum, we can send all the known values of our parents also, I think. Yeah, I think we can do that. So how do I copy the sum? The sum is here, the sum is here. So we can just say sum is equal to array sum or what was the original one I used? The original was 0. Was it 0? JKL. 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 It's somewhat known in the array. Bum bidi 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 bum bum. Bum bidi 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 bum. Bum bidi 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 bum bum. Oh no, oh no. I'm missing something. I need a way to add to the quintuplets. I need history. I need history. Okay. I need history. I need history. Okay, I think it's doable. So in the first state, if we say in this one, the historical value here is empty array, then the sum will automatically be 0. So let's assume we are sending an empty array there, and in this case it will be a sum array. Sum array. So this will be the sum array. We'll do all the sum of everything in the sum array. I'm not writing the exact function for this because for every language there's a different way to do all these things. So get the sum of the sum array. That will be our sum. So with that, for us to add the quintuplet, we just say quintuplet. Oh, sorry, quadruplet. Quadruplet is equal to whatever quadruplet is. So let's just use the most conventional way for most languages. Dot push whatever it is. We'll say let us spread whatever our array sum is, sum array, which is this one. I don't know whether you guys can see my screen right now. Let me see. Sorry. Just joining. Gerald, welcome. Miruki. Sorry, Gerald Miruki. Are you a master? Sounds Kenyan. Welcome. So let me just, for some reason my screen is not moving fine. Let me just move this. We are pushing the sum array. Sorry. Let me just move this here. It's not showing well. So we're moving the sum array. We are pushing the sum array. Together with our current value at that particular position. So that will be the array at position. So it's a spread operation. We are pushing this into the quadruplet, and I think with this we should be able to get our value right. Now, to convert it to code. Yes. Welcome. Welcome, my Kenyan brother. Let me see, is there any other person chatting? Okay. Yeah. So I don't know whether anybody was able to follow me properly, but if you were, you you are awesome. So let's just try and write the code and see where this goes. Let me extend this. Okay. So based on everything I've written, this TypeScript. Yep. So we need to, and I'll need to create a new function. Do I need to create a new function? Because I'm not passing the target here. In my hypothetical, on my hypothesis, I didn't pass the target, which means for this thing to be more consistent, I may need to pass the target. I'll just make the quadruplet global also. So should I? Let me do the lazy version. Let's quadruplet. It's too much words. Let me just make it like this. And I will say we have our target. We have everything we need. Looking at our source code again. Not necessarily a source code. It's just jumbled pseudocode. We need to call a function that takes in different parameters. So we need to call, okay, this function needs to exist before our new function. So that will be a function called, let's just say, let me just say recursion. So that will be a function that takes the sum array, which is, I don't want to do TypeScript much here. I don't know why I even selected TypeScript. Which also takes in the level and also takes in the array that we'll be working with. And look at this, we need to somehow also consider the target, passing the target, because we don't have any way for this function to know what our target is. So with this function now, think in the main function. Okay, let me just expand the function first. Yes, let me expand the main function first. Because I'm cheating in a way, because this quad is being set globally. It's not the right way to do it. Rather. But let me just. I'm trying to. My head is so jumbled right now, so I'm trying my best to demystify everything. So our current position, we start at 0 always, and our sum. Sorry, do I want to change sum? Nope, I don't want to change sum. Our current sum is equal to everything that is in sum of array. Which I write son of array, not son of array. So that will be sum array. Is it reduce? I think it's reduce. Reduce this um, we start from 0, but we have a function that gets an accumulator, then a current value, and with that we can say we want to return our accumulator plus our value. That should give us the sum of everything that is here. Which other thing again? The function considers, so okay, we need a breaking point. So if our if the level is less than 0, then why am I writing like I'm writing Python? If level is less than 0, then break. Else. There's no need for else. While our current position is less than or equal to the length of array, so that's array dot length plus 1. Let me just put this in a bracket together, no go cause confusion. Length of array plus level plus length. Okay, length of array, length of array minus level, oh sorry, that will be minus our level plus 1. So we want to always make sure that how do you write while loops again? It's inside bracket, Abby. Don't forget. We want to make sure that we are always at the right level. We go up to where that level needs to stop. So like in our example, we need to know how to move each level till where they are supposed to stop. Sorry, my mouse is not. Do I have a highlighting stuff? Yes, I do. So level 4 should not go more than level, whatever length this is minus the level. Yeah, so I should never go more than this, than if we are considering this subset, I should never go less than level 0. Yes. So yes. Okay, where did I stop? So if no, I'm doing a while loop, so things can go crazy here. So let me just say I position is plus equal to 1. I need to always increase my position. Okay, so if level is not equal to, then we do something. Else, we do something else. So if level is not equal to 0, it means we don't have all the resources we need to append to the quadruplet. We want to reach level 0 before we start adding to quadruplet. So we need to call this function again, the recursion. What did I name it as? Recursion of sum of array our current sum is what now? Yeah, sum plus array at position pos. That's our current sum. So wait, I said I won't send sums again. I said I will send sub arrays. Oh, I'm doing the wrong thing. Sorry. That will be some array and array apples. So I'm creating a new sub array, not necessarily a new sub array. I'm creating a new like sum array. That's the every parent now, rather every point that we have so far, this is their sum. And what level are we in? We are going down one more level, so that will be level, whatever level we are, -1. And what sub array do we want the thing to consider, or rather the function to consider, the recursive function to consider? So we want it to consider a our current array dot slice. Want it to go from our current position to array dot length -1. I think that's how you do it. Let me just check. So if you have an array of 0, 1, 2, 3, 4, 5. Sorry, I hope you can see my console. Let me just zoom in. I'm doing a console check just to make sure my JavaScript is correct. You belong. So if you have an array of this value, so array dot slice of, let's say our current position is am I missing something? Let's say our current position is 0. Yeah, okay, it will be our next position, not our current position. Our next position, okay. It will be our next position. So let's say we were at position 0. We need the next array to be 1. So let's say I want to go from 1 to, let's say 5. Let me see how it looks like. So this is not correct. From 1 to 5. So that will be from 1 to position 6. So okay, from 1 to 6. So that will be position plus 1 to length. Position plus 1 to length. Plus 1 to array.length. That's what it should be. Let me close this. Close. How do I close this? My mouse is not mousing. Okay. Yes, so this is what the recursion should look like, I think. Yep, else, that means we've reached the last level of our array. Is there any question online? Yeah, so we've reached the last level of our array. Let me see what I wrote in our pseudocode, our shitty pseudocode. Yes, so we need to collect our current sum. Wait, am I missing something? If the level is not equal to 0. Okay, I don't think so. So const our tsum, our target sum, our hopeful target sum will be equal to sum plus array at position. That is considering whatever is here in that particular position for that array. Yes. Yes, I think so. Okay. I fear I'm missing something. If the tsum is equal to our target, where did I put target? Okay, it's here. It's accessible to the function, through the function. If they are equal, so our quad can now be appended to. So we can push to our quad our sum array is that how we spell it? Sum array and our current value, array at position. I think that is it. So if this is the case, after the function is run, we can then return recursion. Sorry, can then return target. No, quad. But we've not run the function, so that will be recursion from, what's our function again? Can I minimize this? Yes. So we are taking a sum array, sum of array. So initially to be 0, it will be an empty array because we've not done anything. Our level, since we always want to have 4 levels, is 4, and so 4, 3, 2, 1, 4. Wait though. So we're in level, okay, we're 0 indexed, so it will be 3. Our array will be the norms, and our target is target. Please don't run forever. Perhaps I could just cry. I'm cheating here. I'm supposed to be returning something. I think so. Let's see. Let me just copy this somewhere so that in case my system crashes, in case I'm missing something. Let me see. Code. VS Code. Where are you? Code. Where are you? Why is he doing Google search? VS Code. Where is my VS Code? Just do new and paste. I want to be ninja. Okay, test case. Okay, my while loop is increasing. Okay, my recursion breaks when the level is less than 0. Okay, does my level reduce? My level is always reducing. Okay, and my while loop breaks when position increases to the point where okay, let's see, let's run this. Some array. Did you mean some array? What did I define it as? Oh. Okay. Expected 4 arguments, got 3. Okay. Expected 4 arguments, got 3. Break. Where am I giving 3? Oh, okay, sorry. 1, 2, 3. Oh, target. Okay. Jump target cannot cross function boundary. What does this mean? I don't know what this means. Have I seen it before? How to break? Okay. Oh, I can't use break for. Huh. If. Okay. So let me just do this. If level is greater than or equal to 0, that's the only time we should do all of this. I think that should work. I think so, yeah. If not, the recursion should break now. I should have just done a return. Okay. Okay. Target is 8. Okay. The expected. How is this equal to 8? Well, how did I get these answers? 1, 2, 3, 4, 1, 2, 3, 4. How? If T sum is equal to target. 1, 2, 3, 4, 5. Where did it get 0 and 1? Oh, okay. I cheated. My cheating has come to bite me. So my global variable, it's still being reused. Okay. So let me just see. Quad. So quad is equal to, let me just always unset it, but I still will fail because it's not unique. It will still have this 2, 2, 2. So I need to check whether my array is in the quad before I can add it. So that will be if, sorry, let me just cut this and say it is new quad. So that will be new quad is equal to this. That'll be a const. Sorry. If And how do you check if array includes another thing in JavaScript? Can you check whether array includes another array? So array, let me see. Let me make it simple. 2, 2, 2. No, I need an array that contains an array. 2, 2. Why did I write 2, 3? Okay, let me just do 2, 2. Ah! So now be array is equal to this. So can I say array dot includes? Oh. What did I type? Oh, where is it? What? 2, 2. 2, 2. Does it include this? So apparently JavaScript would recognize this. Okay. Okay. I can't check. Wait, let me see if error has been set. It's there now, Avi. Let me just do JSON.stringify. Oh, JSON.stringify R. It's there. Can I cheat? I think I can. Dot includes. She's a bad mama jama. But won't this add much much computing demand on the check? Ooh, how do you check whether an array is in an array? Okay, I can just do a find. So in array, find whatever object we fall on, where that object is equal to 2, 2. Didn't find anything. Find 2, 3. Am I missing something? Is it find? Is it index? Where object is equal to. What am I missing? Arrays are not equating in JavaScript. Something is not right. Is 2, 2 equal to 2, 2? Let me see. They are not the same. JavaScript no go kill me. Oh. They are not the same. Okay. I don't learn something today. Okay. I didn't know this. I didn't know this at all. So if I stringify it, it will work. This is strange. This is strange. So how am I supposed to find Find that pair. I don't want to stringify. Stringify is the easiest way to do it, but it's strange that I can't do an equating search. This is real strange. Huh. I didn't know this. Okay. Let me just do the lazy man way. Do di do ba da do ba be do da do ba be boom ba de do ba na do. Come on, let's go. Stringify works. Strange JavaScript. Waiting we no go see. Ah. JavaScript no go kill me, oh. JavaScript no go kill me, oh. Just say it's existing in the array. That will be quad, no, JSON.stringify quad dot includes how do you put new array? I need to check this. Yeah, let me just use another JSON.stringify back. I have tired. I just say it's not existing in the quads array. I think this should work. Okay, 2 cases pass. Woo! Woo! Writing the algorithm helped. Help! It helped. Woo! Wait, somebody is supposed to text me something. Thanks. Okay. Hey, Peter. Let's see. Let me submit this. If I submit, will it save it? It doesn't save. It doesn't save. Oh, it doesn't save. It doesn't save. Oh, wrong answer. I'm missing something. This is 6. This is 9. 9 minus 6. Huh. Oh, I missed something. I did not sort. How did I miss that? You will shine. That was the first thing I said I will do. That will be nums dot sort. When you get A and B, we want it in a way where A is less than B. I think that's how you do it. Oh, I didn't send it. Sorry. Let me just copy this. I'm not sure how you do it, how you sort again. I keep forgetting this thing. So let me say I have nums, which is equal to some random numbers. If I run this, it sorts it in ascending order. Okay, it's correct. So run again. Submit. Hopefully this should fix it. Exceed time limit. Okay. I'm guessing my sort not efficient enough to run how many? In a way, I think the code is not oh boy, it works, but it's not efficient. Okay. Okay. What am I missing? So for each level, it's 4 levels. It always has to wait till we get to level 0 before anything can happen. Is that why it's slow? Oh, lule. Too slow. It's too slow. Too slow. It works, but it's too slow. How can I ever? In other words, this is more than a cubic operation, because it's not really dividing the work into 2 places. It's going linearly. How do I make it faster? How can I make it faster? It worked well for 226 cases out of 294 cases. I don't know what to do. Chat. Do you have any way to help me here? I don't know what to do, man. I don't know. Oh. It's not memory. Didn't run out of memory. Execution. It took too long to run. But the question is, if we've run from the other side, we know their sums. We know their sums. There are optimizations I can do. Okay, let me go back to my notes. I hope you guys are not seeing my pin. Okay, it's not showing. Okay. I think the optimization we can do here is this. We know all the combinations here. And in theory, we know all the combinations here. Is this thing showing? Why is the audio mixer up? Is this showing? Okay, yes. We know all the combinations up to here. What if instead of trying to get the value when we are at level 0, for every level, nah, will it work? We return the subsets of all the sums. don't know how to improve this stuff. Conceptually, I do, but programmatically, I do not know how to. Ah! Ah, ah, ah. Ah. I need to stop repeating some operations. Mm-mm. Hmm. I can hold it in memory. Pinya! So in theory, L will always move from here to here to here. And we do it every single time. But there's no point in doing it every single time since we've done it once. L will always go from here to here. So all the combination of L can be accounted for as 1, 0, 1, and 2. 0, 1, and 2. That means we can save this somehow. How do we save it? Thousand 300 megabytes of memory. He has the forehead, and after head. On the head start, front to lobe, front to globe, until we have to destroy. Why do we still need his forehead? I think I find some. Subira, come in. Come in. Mm-hmm. Oh, I think my issue is this while loop. Oh, my brain. My brain is scattering. My brain is scattering. What what if I increment the position and not the level? Uh, it will never lose its power. Position and not level. Okay, I think basically the recursion of the first should be the recursion of the second, should be able to write it in form of recursion. Ah, so wait. Recursion of recursion of I. So it's a combination of I is equals to the recursion of I plus 1. A, B, C, D. So the recursion has to be the value of another recursion. All combination. I need a recursion that returns an all combination. And based on the all combination, I then find okay. Can find the all combination, all combination, all combination. As long as I is okay. Returns the all combination every single time. So that would be the only way I can make sense of this is to hack this. Let me do this. Create a duplicate of this. Recursion 2 takes n. Do I even need level 0? It's a rough idea. I'm not exactly sure I know what I'm doing. Outcome.filter where the combination is a reduce um, which is equal to roughly the same thing. Not sure. So I want to do a recursion that gets me all the combinations. So if I get all the combinations, um, then I should be able to filter which combination is of length 4. Okay. Which combination where the sum is equal to the target, but that's not going to be the only thing. So I also need to how do you do unique? Can't do unique here. Let me just return all quotes for now. My recursion is still not correct. I need to be able to do a recursion of my array and my level. So my level is 4. Target won't be needed. The array is supposed to return all combination. Mm-hmm. In other words, the sum is not needed here. Position is somewhat valid. So based on each position, I want to say position plus equal to 1. Preserve the combination to be equal to an empty array. Return the combinations my head is aching me. So combinations dot concat. I hope that's the right one. Yes, concat. What we get as the recursion. No, concat our current position array okay. Recursion 2. Recursion of level and asserted array. Object.length is equal to level plus 1. If I always get level, the next level I'm always getting should be equal to, I think this is useless. So let me just map this to be equal to array at post then spread the object. Let me just say combination so that it doesn't get confusing. So there's also the aspect of if the level compile error, cannot find new combinations. Expected for argument got 2. Okay. Did I ever use target anywhere? Nope. Target is used only once. Okay. Expected for argument got 2. Filter does not avoid. Cannot find array sum. Array sum. Where I see array sum. Okay, array sum. Recursion 2, sorry. Cannot find array sum line 50. Line 50. Oh, Encounter the problem occurring at work. Okay, will you encounter the problem occurring at work? Which problem is that one? I don't get. Okay. Target is 0, output is empty. Okay. Strange, but still progressing. Oh. Okay, so combination. It's me. far as position is okay, I'm missing something. I'm not returning anything ever. Yeah, that's the problem. But even if I'm not returning anything ever, okay, it has nothing to loop through. Okay. Okay, so let's just say if is equals to 0, we just say pause. I mean, that should fix it. So this will always return something. I need a recursion that returns a recursion. Need a recursion that runs a recursion. Abi? This basically still does the same thing the other one did. Abi? I don't know. Let me try. I think I'm missing something though. Comb is not iteratable. The recursion is supposed to return an array. The array the current problem you are solving. Okay, will you encounter the problem occurring at work? Most likely not. But I still need to know how to think through problems so that depending on whether I meet something that I need to go through this kind of complexity, I won't panic, I won't have issues. Okay, not returning anything. What am I doing? Okay. Combinations.concat. Concat doesn't add anything. Okay, it's supposed to be combinations. Nations is equal to combinations.concat. Okay. Okay. Wrong answer, but it's progress for me. Expected what? Okay. This is 1, negative 1, 0, 1, 0, 1. 0 is 0, 0, 1. Well, I don't know where I get 1, 0, 1. Where did I get this one? It's supposed to be 1, negative 1, 0, 0, 1. How did I get 1, negative 1, 0, 1, 0? I'm guessing it has something to do with this guy. Okay, let me see the other test case. 222 returns nothing. Huh. Huh. Mm. Hmm. 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 It's not fixing the issue. It's not fixing the issue at all. The first example was more elegant than this. Ah, what did I do? What did I do? What did I do? Hmm. Okay. I need a proper debugger to know what's going on here. So I will have to shift to VS Code. No idea what's going on. No smidget of an idea. Do I know what is going on? Where are the test cases? Test cases. How do I take on this one? With desktop work or no test JavaScript. Quad.js. Ah, it's in TypeScript. Oh. I think that's all. Where is the code where I copy? All this thing I copy, where they? I copy recursion too now. I mean, you didn't copy. That's strange. Oh, okay. Who they chat me? Chide. Hello, Chide. Chide. Hello. Ah, hello. I'm on stream. Oh, is it urgent? Okay. Do di do do di do do di further. What is this? Do di do 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 CD desktop test JS LeetCode test desktop test. Okay, LeetCode ls node quad. Okay, nothing printed. Dun, dun, dun. Console.log combinations. Okay. Venom. Venom, 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 venom. I'm gonna taste my venom. Venom, venom. Okay. It always ends at 0, which is strange. I don't know if you people can see it. It ends at 0. You got a population. How does it turn to 0? Okay, let me go to the bare minimum. So it stops at 0, 0. Did I hard code 0 anywhere? Array pose. My filter is wrong. I know you heard the rumors. you know me tonight? That's the question. Everybody tonight, that's the question. Bow, 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 bow. I know you heard the rumors. We just a sing with you, no, yeah. Okay. Ula, ah, ula, ula, Why is this sum not correct? If I have an array of all coms and I'm filtering through all of them and I'm saying reduce the value of the accumulator, makes no sense. Okay. Instead of doing a filter, let me just do a map. Maybe that will show me where the problem is. False, 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 false. Okay. But this is 0 there now. Waiting this thing they tell me. So this reduce doesn't equal to 0. What is it? I don't get it. 0 doesn't equal to 0. Everything is false. Let me write 0 myself. It's true there now. Everything is in the talk. So when I put plain, oh, did I send a target? Okay, sorry, my bad. 0. Okay. Filter. Okay. I think then the problem is from me. I didn't do this well. Array of position. So let's run this again. I don't think this solved the original problem. Two zero zero two. Didn't fix it. 2002. Yep, there is something missing. Ah, I need to. I'm a little confused. This might break the system, but let me just try. What is the 002? There's 000 here. How is that even possible? And there's no 002? Is it that it's never reaching 2? Yeah, it's never reaching 2. Yep, it's never reaching 2. It's reaching 1, but it's never reaching 2. That means my slice is wrong. Two is repeating now. First it didn't reach 2, now it's repeating. Anyhow though, if you guys are joining me, please, you don't have to stay to the end of the stream. Right now I'm just trying to struggle to find my problems. Anybody who has joined so far, thank you for joining. I will see you guys later, but I will continue with the stream. It's going to be boring from here on out. Sorry. Thank you. Okay, let me check the lower combinations. Maybe I can find what is going on. So the lower combination is saying 00. Is it not sorted? I sorted it, right? Yep, I did. And I get negative 1, 1. My position is less than. Whew. No idea why this is double. No idea. Boom, boom, boom. How did we even get 0, 0, 0, 0, 0? We only have 2 zeros. So where did we get all these zeros from? Too hacky, but I think I found the solution. Okay, makes sense. How do you even check for unique arrays? I think the same logic can work, yeah. so tired right now. There's no need to for this one. So hungry, Mr. Hungry. I have nobody for food. So hungry, so hungry, so hungry. Mr. Hungry, all come, after all come, after all come, after all come. Sweet, 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 sweet. I don't think this fixes the original issue, but let me see. Don't think it did. Don't think it did. Don't think it did. Don't think it did. He didn't fix it. Ah. I was broken from a young age. Pain, you make me a believer, believer. 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 I'm missing it. I do not know what to do. I do not know what to do. What to do. I'm missing it. I'm missing it. I'm missing it. I'm missing it. I give up. I have to check the answer. I have failed. I have failed. I got the answer, but it wasn't efficient.
Hi everyone, today we are going to solve the LeetCode question for sum. So you are given array nums of n integer return array of all the unique duplets A, B, C, D, E. And now
My code wasn't efficient, but it was working. Okay. What's the time? It's almost 9. Oh, it's 9. Can I still game? I think I can still game. 2 for loops, I and J. Okay. This is complicated though. Another while loop for the left, another while loop for the right. One left is left and right. Nums on IJ, nums on left, nums on right. I remember when, I remember when. Time to say goodbye. Oh, thank you all for joining the stream. My code was not efficient, but it was good. It was good enough. You people should go and learn how to improve it. Thank you for joining. I'll see you guys and gals, if any gals are here. Later. Bye-bye. We forgive you. That's a good one. Bye-bye.